Probability density functions. It is important to note, so important that I'm going to repeat myself from the previous lesson, that since the variable is continuous, there are an infinite number of individual values that could be taken. Thus, as mentioned earlier, the probability of any individual value being taken is 0. Hence, if you are asked for the probability that x equals 3 for a continuous random variable x, you will always write the probability that x is exactly 3 is 0. We can, however, talk about the probability that x takes a value in a given range. This gives us the idea of probability density, i.e., the likelihood that x lies between two values. Typically, the graph of a PDF is a curve, and the total area under that curve is 1. We know that the total of all probability must be 1. So, for example, it might look like this. We might have some sort of curve here. We can see, since this is probability on this axis, that it's more likely to be here, where the curve is higher, than down here. And then we can find out the probability of being between any two specific values. We could state the PDF as f of x is equal to p of x for x between a and b and 0 otherwise. So really what happens is our PDF continues outside of a and b like this, but the probability is always 0. It can't be along those sections. All of the probability is concentrated between a and b, and the total area here would be 1. With continuous distributions, it does not matter whether we use a is less than or equal to x is less than or equal to b, or should I say x is between a and b inclusive, or x being between a and b not inclusive, as the probability that the variable actually takes the values a or b is 0. Remember, for any particular individual value, the probability is 0. So just be consistent with the question that you're given. If we wanted the probability that the variable was to take a value between, say, c and d, if we know p of x, that's the function that gives us this curve, we can calculate this using an integral, the integral between c and d of p of x dx. Any probability density function must satisfy the conditions that p of x is greater than or equal to 0 for values of x between a and b, and the integral from a to b of p of x dx is equal to 1. So what we're saying is that the curve must be above or at least touching the x-axis and cannot be below in any way, and the total area under the curve in the specified non-zero part between a and b must be 1.